Hey guys, it's Julianne, and I have to admit something. So my Rube Goldberg machine did not accomplish its goal. However, almost the whole machine worked except for the goal part, and I did try my very best. So regarding that, I was going to make my Rube Goldberg machine stack a sandwich. However, it went into a bunch of ingredients stacking onto a plate instead of actually stacking up into a sandwich. So my goal kind of turned from stacking a sandwich into putting stuff onto plates. So as you guys can see, at the very end, the ingredients don't stack up together, so that's why it's not really a sandwich. This is the slow motion version, and one little disclaimer is that I don't really think the sandwich would be edible anyways. So as you guys can see, I've labeled my graphs from step 1 to step 3, and the white numbers are going to be for the first graph, the purple numbers are going to be for the second graph, and I divided them into two graphs because there are two steps occurring at the same time. So the GP in the system is mainly going down, while the K in the system is mainly going up. When the ball rolls down from the board, it will stop, then advance slightly upwards, and continue going down. This will cause the GP to go up a bit and the K to go down a bit. When the ball enters the cup, there will be a small amount of time that will involve no movement. So the K will go nearly to 0, then go up like it's the GP when the mouse moves up. When the mouse hits the other dominoes, or the dominoes hit other dominoes, there will be a slight moment without any movement. So the K will go down. When the ball falls down from the pink board to the green board, it will stop and bounce up a bit, and which will result in an increase of GP and an increase of K. This will be the same for the last 5 boards. The thermal energy in the system is almost the same as the kinetic energy, except when the kinetic energy goes down, the thermal energy will stay the same. In the end, when the ball pushes down the toast into the plate, the GP and the K will go to 0. So the first step of this graph is nearly the same as the last graph, except the only difference is the GP. So the GP will be going down from the ball enters the cup because the system is mainly on the cup, and the cup is going down. So another thing is that when the cup hits the other dominoes and the dominoes hit the other dominoes, there will be a slight moment without any movement, so the K will be going down. When the domino falls onto the pink board, it will not move at first, but then bounce upwards towards the green board. This results in the GP from going down to going up, and the K from going down then to increasing. So when the dominoes hit other dominoes, there will be 6 ups and downs in the K and the GP, since the domino will move for a slight movement and the GP is changing because the dominoes are falling down. When the ham and cheese fall into the plate, the GP and the K will all go down to 0. And for the thermal energy, it will increase with the K, but when the K goes down, it will remain the same. The change of direction in this step is 90 degrees to 180 degrees, mainly because the domino was originally going to fall horizontally, which is 90 degrees. However, there was nothing preventing it from falling down vertically, which is 180 degrees. So it went from 90 degrees to 180 degrees because it was originally going to fall horizontally, but it fell down vertically. So I added friction to this board because the ball that is rolling down from it will roll into a cup, and if the ball doesn't slow down, it is nearly impossible for the ball to get into the cup. So I don't have any large surfaced objects in my Rube Goldberg machine, so I decided to use this example. So when the ball falls down from the pink board to the green board, there is going to be a lot of air resistance because it's falling directly down. So in order to decrease the air resistance, we can use a smaller ball because there will be less contacting surface area. So this is my force calculation. This is my pressure calculation. And this is my work done calculation. So this is a picture of the work done of the distance between the Jenga blocks. So the distance between the Jenga blocks is 3.5 centimeters. So in my Rube Goldberg machine, I use levers, pulleys, and inclined planes. And that is my Rube Goldberg machine. So thank you all for watching my video.